Okay, so first of all, guys, thank you for inviting me to Chicago Crystal, and thanks for joining. So I'm going to talk about the static code analysis in Crystal, and also about my personal project called Ameba, which is about to do a static code analysis for Crystal shards. So I'm going to show you some examples of how to use it, and then we will talk about some Ameba internals, which is I find quite exciting. Okay, so let's get started. So let me quickly introduce myself, especially my contribution to Crystal community. So probably you have seen my GitHub profile, and one of the most popular things there is Awesome Crystal. It's like a created list of crystal shards, and so there are people who help me to support and maintain this list. It's not that easy as it looks like because a lot of shards become outdated and they have to be removed from the list, or new shards are created and they have to be added. There is some automation around that, but anyway. And the next thing I've been working on for a while is Crystalline. It's like a website to announce some projects, blog posts, or any other work related to Crystal. It's quite similar to what Reddit's supposed to do, but there are some integrations with social networks, also some RSS and stuff. And there are a bunch of projects I've been working on, so I included some of them which have some nice logos. First one is lua.cr. It is about to. This is just an interface for Crystal to be embedded to Lua, and Lua to be embedded to Crystal, which is also quite interesting. There are some Crystal patterns which are intended to implement Go patterns. Also, I'm a member of Crystal community. If you haven't heard about that before, it's a GitHub organization which is intended to have crystal shards which are outdated already. I mean that some people just start working on their shards. They work a couple of months and then abandon them, but other people just need them to be working. And so the Crystal community is about to maintain those shards. There are a bunch of quite popular ones like ICR, Interactive Console for Crystal, Message Pack, and so on. And also I'm a member of Ember framework community. Ember framework. Yeah, you probably heard about that. It's one of two most popular frameworks for Crystal. Yep, and the most interesting project I've been working on is Ameba. It's a static code analysis tool. There is a Crystal organization for it, and there is a website and a blog post, and also it is quite popular in Crystal community. I just wanted to show you a couple of statistics. For example, there is shards info website which is designed to be quite similar to Ruby gems, but for crystal shards. So here you can find some statistics about some different projects. And for example, Ameba is used by 100, just a bit more than 100 shards. Well, actually, it's not. It's just a half, because at some point Ameba was moved from my own profile to its own crystal GitHub organization. So you can take a look into the old place, and there are still some shards which use the old handle, like another half of them. So in total, it's just a bit more than 200. This is not that much, but when we're talking about Crystal, it's a young language, and I believe it's not bad statistics. So why people use that? Yeah, because so Ameba helps during the development workflow. So it is intended to detect some code smells and detect some potential bugs at early stage, meaning that you can run the Ameba just before you run the tests. So it will report you some probably some bugs and maybe syntax errors, just quite similar to what the Crystal compiler does. And there are some automation. There are some tools which allows you to run, for example, Ameba based on some trigger. For example, when the file is changed, so you can open your file, edit your code, you can save it, and see the results in a different screen, in a different terminal window or something like that. And so Ameba wants to enforce some consistent Crystal code style, and yeah, there is one, and it's unofficial documentation. It is pretty small, so there is some naming for variables, for method names, and so on. But still people can violate this, and it's quite nice to have some standard, and especially when it can be detected automatically. And of course, it forces your code base to be more readable. That's the intention of static analysis and so on. There are also some performance like rules embedded to Ameba, yeah, which helps you to detect some bottlenecks as well. And so let's take a look how it works. So Ameba is just it can be compiled just to a binary, and you can run it directly in your repository. For example, here is I use the Ember repository, and I intentionally added two linting issues. So there is a progress bar which quite similar to what Crystal Spec outputs. It's a green dot, means that your file pass a test, and red F letter means there is an issue. And there is an output like kind of readable, I assume. So it shows you the best file, a point at the file, also the name of the rule which causes the issue, and the message, and also a small piece of affected code. So what it says here is that it found the useless assignment, meaning that variable foo is probably assigned, but it was not used below. So it doesn't make any sense to have this assignment in your code because it is not used. And there is another issue which says there is unreachable code, and meaning that this code cannot be reached in your method. But for example, because let's assume you just have a return statement just above it, so this code will never be executed. So this is like some small things which are not reported by the compiler, but we are able to do this at this point when we run the linter. And yeah, and it brings some statistics like just a bit than 200 files were inspected and there are 2 failures and so on. But that's just a basic example of using the Ameba, and there are much more ways to use it. So the first one was CLI binary, and then you can use the editor plugin. Like there are some available plugins for Vim, Emacs, and Visual Studio Code, and a couple of others. And also Ameba can be used as a Docker image, meaning that you don't have to compile a binary locally, install Crystal or something like that. You can just pull the Docker image, mount your folder with sources, and Ameba will run the linting just inside the Docker container, and you will see the output. And also, Ameba can be used as a development dependency. This is usually used to write the extensions for Ameba or for some integrations. For example, there is an integration for Codacy. It's a resource it's like a website to show you the coverage, also the linting issues, and so on. There are a bunch of tools available. Among them is Ameba, and to be able to integrate, we can use like a public interface of the library and use some pieces of code to load configs for loading configs, for running linting, for formatting the results, and so on. And Ameba can be used as part of the CI workflow. It can be added to Travis Circle CI and so on. Recently, the GitHub Actions were implemented, so they are also available. And as I said, Codacy and similar sites. So let's take a look at a few examples just to understand how it looks like. So here is my local setup. So I'm using the Emacs, and I have installed the Ameba plugin. So what it does is basically it highlights a point at which the at some point in a file, like a column and line, there is a linting issue. So if I move my cursor to that point, it just shows me the similar string you have seen in while we on a previous screenshot when we ran the Ameba through the CLI. So it shows the name of the rule which reports the issue, and also an error message, and so on. And basically, what it says here is that the literal value was found in the interpolation. So if you look at it, you will see that there is a number 31 which is used just in the interpolation, but it doesn't have any sense to do that because we can just omit the interpolation, and a number 31 can be a part of the string. So it's being reported by Ameba. And below there is a list of issues in current project, and it's sidekick.cr. So you can just run it through your editor and fix it step by step and so on. So you don't have even run it through the command line interface. And there is another example, as I said, there are GitHub Actions for Ameba can work with GitHub Actions. What it does, it can be a part of your CI workflow, and then it appends the annotations to the code. So, for example, again, so there is an useless assignment to is initialized variable. So it just depends that handy, annotation, and it's available just in your PR. So you can you don't have to review that too carefully and focus on those issues. You can just install Ameba as part of your CI, and it will show you those handy errors. And the reporter will have to fix that because it fails your CI workflow. Okay, so the rest of the slide. So I have shown you some examples and the way how Ameba can be used. I think it's pretty clear that it has to be pretty flexible and configurable, because it can be used in a different ways on as you saw on CI through the CLI binary, or in editors. There are also other examples. So keeping that in mind, I would like to think about how would you implement it from scratch. So meaning we just need to answer a couple of questions. What it should be able to do in order to satisfy the requirements we have seen before. So it is definitely definitely it should be able just to load the source code. Yeah, because without that we wouldn't be able to run source code analysis. So it is obviously we need to somehow read our source code and load to the memory and pass it to the next step. And what will be the next step? It's so it is different. It is, I believe it is clear that it is quite hard to work with to analyze the code in its original state. Meaning you have read a file and it's just one string or maybe an array of strings. And how would you analyze it? Because you want to find those unreachable codes, useless assignments, and so on. So it's definitely it is obvious we need to transform our code to something more useful. And probably there are a bunch of ways of doing that, but what Ameba is doing, and probably most similar tools, is that such a tool must be able to parse the source code into the AST nodes. AST means abstract syntax tree. So basically, we want to transform our source code into the object model, and that would allow us to work with that efficiently. We will see how it works later. So once we transform these two AST nodes, we would like to be able to traverse those AST nodes and catch and at this point we want to catch those linting issues because we are able to, because we are working with the AST nodes, not without just the strings of code. And at this point we would like to define, probably we would like to define some specific rules which would enforce some rules, some rules, some tests probably for our nodes. So these rules they will traverse our AST nodes, and they will test them and add linting issues to it, if any. And the last step of this process would be probably formatting the results. So as you saw, there are different ways to display the data, to display the results of this linting process. So we have seen the annotations on GitHub. We have seen the just some information in the console, right? And also we have seen the editor plugins, which also display information differently. So probably there should be some like formatters to display these linting issues in different ways, and maybe with some statistics. And we can try. So if we would try to visualize this, we can do something similar to this picture. So at the beginning we have a code. It's like just for example, it can be a file or anything else. It can be a pipe, I don't know, a stream or anything else. But this is crystal code we want to analyze. And there are 4 stages it has to go through. First one is loading, when we load the source code. Then we want to transform that to AST nodes. Then we want our rules to traverse those nodes. We want to format the results. Okay, so I'm going to go through each of one and explain. So let's start from loading. That's the simplest one, actually. So how could it look is that we just have a file which holds our crystal code. So there is a path to this file. As I said before, it's not necessary to be a file, but for simplicity, we just will assume this is a file. So what we could do here is we can just read this code to the memory through the known utility methods like file.read, passing the path to a file. So we have loaded our code to code variable. And at this point, we could think about some abstractions like that would simplify our work later. So what Ameba does is that it has a source abstraction. It's like it's just a class that accepts the code and the path to the file, and it has some handy methods. We can just look at the code. As you can see, we just loaded some small piece of code. It's a class with a getter with a method, and there is a call to puts method which prints some information to stdout. And there is another method which could indicate whether this source has issues or not. So it's just source.issues, and at this point we don't have any issues because we don't do any static analysis. Okay, so that was as simple as this. So what we did, we took our code and just transformed that to our source abstraction. The next step is a bit more interesting. This is AST parsing. It sounds complex, but Crystal actually just have a compiler which already does this. So Crystal's compiler internally, it is obviously transforms a source code to AST nodes internally, because how the language works. And the nice thing about Crystal is that we can actually reuse that. So we can, there is a syntax module inside the compiler, Crystal compiler, which utilizes a bunch of handy abstractions. So in our case, what we do, we just use a Crystal parser. We pass a source to it. Oops, sorry. We pass the source to it, and then we call parse on this abstraction. So just look at the line above. Our source, for simplicity, our source is kind of different now. It's just a simple assignment. We assign 1 to variable foo. So we parse our source, which is assignment, and as a result, we receive AST nodes. This is as simple as this. So we don't have to implement our own parser or so on. It's just available in Crystal's compiler. And the result of the AST node is it's a pointer to. So AST is like an abstract syntax tree. It's a tree. So it's a tree representation of our code. And the top element of this tree is some node. In our case, it's Crystal and assign. So there are a bunch of definitions of for AST nodes, and for any language construction, there is a definition in the abstract syntax tree, and there are. So this is not documented, but this is available. So this can be read just inside the Crystal repo. So, for example, there is a file that defines the whole list of nodes, and one of them is assign. So this is a definition of our assign expression, and so this is just a class which defines the assignment. The assignment. So it has two. Obviously, it has two important properties. It's a target. It's a target we want to assign to, and it's a value. And if you look to the right, so the type of these properties are also AST nodes. So AST node is like an general class for all the AST nodes. So here we have a target which is of type AST node, meaning that it doesn't have to be a variable. It can be it can have a different type, like instance variable or anything else. And for example, a value, it doesn't have to be a number, just like in our case. It can be a string or even an expression. So the AST nodes, they have properties with child elements. And if we look, if we go back, we can see that our AST node, our root element, is an assignment, and a target value of our assignment is a crystal var with the name foo, and the value here is a number literal, and its value is 1. So basically, target and value, that's different AST nodes. And so basically, we have a tree, and this kind of simplifies our task because we want to implement the linter, right? But it doesn't clear for now how would we, go through this tree and find what we need. Because let's assume, so this is quite small program, like just an assignment, and let's assume there is a file on 100 lines. So it could be quite difficult to efficiently traverse that tree. And yeah, so that's a question for the next step, because we want to traverse as abstract syntax tree by the rules. But what Ameba does is that it just utilizes that crystal's behavior. So we had our source, which is a source abstraction in Ameba, and there is a method which just returns the abstract syntax tree. So if we want to print out the top level node, it will just show you the code. But if you look at the class of this top level element, it will be a class definition. Yeah, so we are able to parse our crystal code, and we have our AST nodes. So what it means that at this level we just transform our source code to the AST nodes. And what is next is that we want to traverse them through the rules. The nice thing about Crystal again is that it basically does the same under the hood when it compiles your program. So basically, it has some abstractions which allows you to work to traverse in the nodes, and this is called visitor, which is quite popular pattern for doing that. And this is also available under the syntax module in the compiler, and the interface to work on is that looks like that. We need to define our own visitor, which is called my visitor, and inherits the crystal visitor. And we want to define a method inside it, which accepts a single node, and this node can have a type. And this is actually quite important because this allows us to filter out the nodes we want to work with. So, for example, before we had an assignment in we had a our top level element was an assignment, but once we accept those nodes result of the parsing by our visitor, we can filter out for example, a variable, a crystal var. So in this example, there is only one variable foo, and when we are able, so because it's guaranteed that node is of type of crystal var, it will have a name property which is defined in a crystal compiler. So it would be a var. So, and the rest of the nodes, they are passed to the general to the general method which accepts the nodes of type AST node. And this also always returns true because the result of this operation, it is used to decide whether the child nodes needs to be traversed. So in this case, we just traverse all the nodes, and here we just filter out our crystal var. So this looks quite useful for us, since we want to use to do the static analysis, because at this point we can take our code and find only those nodes, filter out only those nodes we want. Regarding the visitors and parsing, there are like some useful projects which helps you to understand how it works. So the core developer of Crystal, Brian, he has written some nice interface that shows you the result returned by the parser, formatter, and etc. So this can be quite useful for the developer who wants to inspect the result of the parsing or etc. And another one is quite similar, but it just has a different output. It just prints out the abstract syntax tree to console. Yeah, so here we are able to traverse our nodes, and what it gives us is that we can start defining rules and try to traverse our AST. So rule in Ameba is it's just a struct which inherits a base interface, and the entry point here is that a method test. It's just a callback where the source is passed when we do the linting. So what we can try to implement a new rule, which is called no puts, meaning that this rule will disallow calls to a puts method. It's quite similar to what, for example, ESLint does. It just prevents you to have a console.log in your JavaScript code. And yeah, so let's try to do something similar in Crystal. So we can define a new rule which is called no puts, and we would have to define the method and entry point for this rule, which accepts a source. So what we have to do at the next step, we probably would need to take the AST of our source and find all the needed for us nodes, and those nodes would be of type crystal call, because it's a call to a method. So if we would like to find for example, a definition of a method, it would be crystal def, like a definition of a method. But here we just call a method because puts is already defined, and somewhere in our code we just call it, execute that. So it's crystal call, and the name of that AST node would be puts. Okay, so let's try to do that. So as I said before, there are some visitors, crystal visitors, and Ameba, it just has some abstractions around that, so we don't have to write some boilerplate code in all the rules. So there are some like node visitors which just starts traversing the source AST nodes and pass it down to the test method, which now accepts a source and a node with our type. And what is important here is a type, because it allows us to filter out only those nodes of type we need. And in this case, it's crystal call. So, but we don't want to report all the crystal calls, because there are lots of methods to be called. So we just aim to filter out those which have name puts. So if it's not node of name with name puts, we just return. And if it's a case, we just add a new issue to the source. And to do that, we just pass some references and useful information, which will be displayed during formatting, during the output. So we pass a reference to a rule who reported that issue. We pass a reference to a node, AST node, because it holds the position position of the issue in a file, and we pass the message which will be displayed to the user. Yeah, so what we did, we just implemented the sort step. So basically, we change the AST nodes. We traverse the AST nodes, and we add issues to the sources. Issue is just another abstraction which utilizes some properties like severity and similar stuff. So the third step is formatting. Of course, there are some more abstractions in Ameba, but it could be done in a different way. So there are different kinds of formatters. Definitely, because we need to report to different places, like to GitHub Actions, to editors, to console, and so on. So there is a dot formatter, like you report those green dots. There is a JSON formatter, and fly check, which is needed for editor integration, and so on. And also the pretty important ability of formatters is to use different IOs, because at some point we want to send results to std out, and in other cases we want to send results to network, and so on, or write to a file. So what we have now, so basically on the left there was our source code. As you remember, there was a class with a getter, with a method, and inside it we had a call to puts, which prints some information to the console. And on the right, on the right is a result of our linting. So we loaded our code, we parsed AST, we traversed that, and we added an issue and reported it. So the format of this JSON is it's kind of defined by the one which is implemented in Ameba library, but it can be different for sure. So here, for example, you have some metadata which shows you Ameba version and Crystal version, and also there are sources. So sources in this case is an array, because Ameba is able to work on a list of files, of course. But in our case, it is just one file we tried to inspect. It has a path, which was defined originally. And there is an issue. So issue is defined by the message, like a puts method is called. a rule name, meaning that the rule who reported it severity, and the location. So as you can see, location is holds to properties. It's a line 5, and column 5. So this is this point, like at letter P. Whoops. And the end location, this point. So what we did, we just implemented our formatter, and we had some output, a result of our static code analysis. And so I just need to say that this kind of architecture, it is available in that or another variants in most of, like in similar tools in linters. For example, Rubocop linter for Ruby just basically just does the same. There is also like Credo is a linter for Elixir language. It is quite similar, and that's because it brings some flexibility. For example, if you need to use a different formatter, you just use some of the available or define ANU, and so on. The most complex part is, of course, it's part 2 and 3. And it's quite nice when language allows you to do that pretty easy, just like the Crystal does. But some linters, they have to to implement the parsers on their own. For example, Rubocop has just its own parser. And yeah, so what we did here is that we actually defined a runner. So Ameba also has a runner which just starts the process, and it's another abstraction which can be replaced because, for example, for Codes integration, there had to be another runner because it works quite differently. And the difference between a runner and a previous picture is that in case of a runner, you don't have a single source, you have multiple sources. And so this is a simplified version of Ameba's runner. So what it does, it has a method run, which iterates through the sources which are loaded somehow before, and inspect each of them. And this method inspect, it basically does what we have seen on the previous picture. So there are some formatter stuff, and there are predefined rules, and the rules just reiterate through the rules and test a source by each of them. And it's quite readable as for me. And moreover, it allows to so this allows us to think about some parallelization. So how could we parallelize this? As you may heard in recent Crystal versions, core team introduced a new feature, like it's still in preview, but Crystal can be parallelized, meaning that it can be run on multiple processes in parallel. And the interface for that is channels. So what we could do here, like the simplest way, is that we can create a channel per source, and that could allow us to parallelize our process. And there are minimal steps needed to, just to change previous iteration to this one, because in this case we just don't have to iterate through the sources. We just have to create a channel per source and iterate through the channels and pass and start inspecting and inspect a source, each source just in its own channel. And once this is done, we just have to send a message like, yeah, it's done. And at the end of the process, we just need to receive all the signals from all the channels. And yeah, it's so there is a really small effort needed to adjust that. And in terms of results, of course, we would like to test that. So what we could do is that we have to compile the Ameba with a special flag. It's a preview _, I believe. And once we install that, we can run Ameba on some repo. In this case, I tried to run that on Crystal repo because this is just the biggest Crystal repository available currently. And to be able to parallelize that, we need to pass different number of Crystal workers. So in this case, we just pass 1, 2, 4, 8. And also, in each case, we pass a silent flag, which means Ameba will not print the results to the console. So to improve our test. And and what happens there is that actually, in the worst case, when we use only one worker, it takes around 30 seconds. And in the best case, when we use 8 workers, it takes around 10 seconds. So it becomes faster 3 times, right? It's not like the ideal situation what we would like to meet, and there is an explanation why it's not 8 times faster, right? Because we use a channel per source, and different sources can have different size, right? So we don't divide our process evenly. But well, I believe that this is just a silver bullet between the speed and the complexity of the code. Because if you would like to divide the code evenly, we would have to change our process, change our code base just a lot, because we have to just rework everything. So at this point, Ameba is quite fast, and as you can see, it takes only 30 seconds on the biggest repo. So it doesn't have any sense to do that major changes to the library to achieve some performance results, because yeah, these are acceptable, I believe. Yeah, so that was about the Ameba's internals, and there are a couple of things I would like to talk about. It's are some limitations and challenges. So the first one is that we can't actually rely on the built-in Crystal parser. The reason of that, sometimes it transforms the code, the nodes during the parsing. So here is an example. Let's say we have a this is our source. Like we define a class which is named animal, and we have a constructor, and we use that short syntax, which allows you to define an argument for the constructor and define the instance variable at once. And once we parse that source, it transforms that just to a regular way, not a short syntax. And I believe the reason why Crystal does this is for some internal optimizations, but in our case, this is quite, quite important and difficult to solve issue. Because let's say I would like to write a rule which would enforce this style, and I would not be able to do that through the existed approach, because using the AST parser, I will not be able to distinguish in which case user's code contains a short syntax or a regular one. And there is another risk. Let's say in future releases, Crystal would add some more optimizations to its own AST parser, and Ameba would whoops, sorry, and Ameba would already use some functionality which Ameba would have some rules which depend on some features of AST parser, but Crystal adds some new optimizations, and parser starts working differently. And that it could happen that some rules will stop working, and there would not be an easy way to implement that back. So probably we will have to drop some rules at that point or something. Of course, there are some different ways, not only using the AST parser. There are so first of all, we could actually implement our own parser, which is also a big portion of work. But there are some different ways to. There are some different abstractions like Crystal's Lexer. It's an abstraction which is used internally by parser, but it's much more low level. So it parses words of source code, it parses parentheses and so on. So the output of it would be some chars or strings of code, and not the object model. Of course, it's possible to work with it too, but it's quite difficult because it is too low level. So that was the first one. And another challenge is code autocorrection. So most of the available linters, they are able to autocorrect reported issues. So for example, Robocop has a minus autocorrect flag, which allows you to correct your code in a right way. ESLint has minus fix, and so on. The good news is that Crystal also has some good stuff to do that. It's transformers. So in this case, it's quite similar to what Visitor does, but it just doesn't visit the code, but it also transforms it. Not the code, but nodes. So for example, we have our own. This example is taken from the Crystal examples directory, actually. So we have a class charity, which has a transform method. It accepts number literals and transforms to char literals, meaning that once you run this on your source code, it will transform all your numbers to chars. But that was a good news. But there are also bad news, and One of them is that it's the same. So AST Parser can actually change our source code. So that can have side effects if we start, after correcting our code through this mechanism, just like in the example below. Just like in the previous example, user written this, but we transform that to some different code. And of course, there could be some conflicts with other rules. I believe this issue. So all similar tools face with this issue. So a result of after correction can have, so other rules can complain on the after corrected code. Well, of course, it's possible to avoid this somehow, but it's just not that straightforward. And the last thing is that after correction can conflict with the built-in formatter. Crystal has its own formatter, and somehow we would like to after correct and probably format. And there are some questions whether user used after formatter before, and this is intended or not. So I don't say this is impossible to do, but there are just a lot of things to think about and to do it properly. And the last challenge is, I believe, the most difficult as part of the roadmap. So usually it happens really often that people suggest some rules to catch that or another bugs, and they don't understand that Ameba can do only the static analysis. So meaning that we don't know, we know nothing about the types. Ameba knows nothing about types. So for example, one of the recent issues, which is like a feature request, which were submitted, is that we want to be able to detect whether a user can compare a char with a string, because because it's error prone. So user can just try to compare with a char, and this is false, but he can assume that this can be true. And at this point, Ameba is not able to do that because he doesn't know the type. But in theory, this is possible. So Crystal allows also to do some. Crystal has some classes which allows to do to add types to grab some types for your project, because just because this is a part of the Crystal's when Crystal starts compiling your program, it's a part of the process. But this is not really straightforward, and it could be quite complex. And also Ameba could probably, I'm not sure, but after some investigation, I think Ameba would have to be a part of the compilation process of the root projects, let's say, in order to do that, which is not also the good way. Yeah, so this is everything what I wanted to show you. There are some references, so it's definitely a Crystal Ameba organization. There is a roadmap on Wiki and a blog post. Also, there are references to the code style, as I shown before, and there are some samples which I was talking about in a Crystal repository. There is a sample of using a transformer, visitor, formatter, not that much, but at least something. And there is a nice article for Crystal internals, which could be quite important when if we want to implement a semantic analysis. And yeah, so some credits, like of course it's a Crystal language, because a lot of stuff is used, which yeah, a lot of Ameba uses a lot of internal compilers entities, and so Ameba was inspired by Rubocop and Credo and Dogma. Dogma is another linter for Elixir language, and this was it was actually quite useful to look through the Dogma sources, because it is at initial step, and you can just take a look, and there are not that much abstractions, and you can understand how it works. And also you can take a look into first commits and see some decisions done at this step. So for example, the first rule which Dogma implemented was about trailing spaces. You know, when your source file doesn't have to have any trailing spaces, and so on. And also, I would like to thank you to my employer, who allows me working on my open source stuff. So that's all. Thank you. Sorry it took just a bit more time, I believe.
No problem. I think it's just us left, but I have a few questions for you if you have a minute.
Sure.
Yeah. So how you were showing some of the rewriting that Crystal does with like the assignment inside initializer. Have you run into anything with multi-dispatch where it starts reordering everything for you?
Running with what? Sorry.
There's a feature in Crystal called multi-dispatch where if there are different like interfaces to a function and they are like keyword arguments, they will reorder the parameters like intermittently for you so they can call into the function correctly. Have you encountered any problems with Ameba and like multi-dispatch?
No, there are no such rules in Ameba, but well, it's actually a good idea. So maybe you can just add to a roadmap.
Yeah, when you started writing that down, I was like, oh, man, I wonder what they. I'll have to try to come up. I think what might happen is that Crystal actually with multi-dispatch, I think creates an intermediate function. So Ameba might never find it. Like it might not have a rule because it just does like mass reordering. But it would be interesting to see. I mean, it would definitely show up in like the after post parsing the code, like after you parse the code. But yeah, I love the AST viewer and helper stuff you showed. I've taken a look at those projects. Brian's work on that is pretty cool. Are you going to post the rule samples that you had, the no puts and stuff like that? I thought that was really cool, but it went like I didn't necessarily see how you did that. Do you have that? Do you have the no puts uploaded online?
No, it's not a part of the Ameba, but there is a blog post about that, and you can find all the samples just in the blog post. I believe I just I added a link to that. 1 second. Yeah, maybe I can just show you.
Okay. Will you send us? I'll post them online for you. If you're
sorry,
okay.
What was that?
If you send us the slides, we'll post them online. If you're okay with that.
Yeah, for sure. Yeah, so there is a blog post like for Ameba internals, and you can see there are quite similar stuff here. It was written several months ago, and there is that no puts rule, so you can explore the results as well.
Why is the test on line 4, that function on line 4? Why is that necessary? Why don't you just write line 8 like that source and then the Crystal call?
This one?
Yeah, why do you have to do that at the interface? Why not just do line 8?
Yeah, because test method is kind of more general. There are some other rules which don't have to use the AST parser. It can use the Crystal Lexer. Or, for example, as I said before, there are much simpler rules when you just need to go line by line through the source and find trailing places.
Got it. I guess the last question that I had written down is that is there anything that the Crystal core team or that the Crystal compiler could do to help you out? Is there?
Yeah, a bunch of stuff, I believe. So the most frustrating thing is that those optimizations for the Crystal parser, because I just worry about it a lot. I just think that at some point it could break Ameba. But also there are I found some bugs in parser. So, for example, it doesn't report the correct location of AST node. So node has its own location, and this location, it's a location of it in a file. And sometimes when Ameba reports, it just shows the location of that node, and that location is just not valid because there is a bug in a Crystal. So I believe I posted a couple of bug requests to the repo, but not all of them.
Awesome. I think those are the only questions I have. I was going to stop recording unless you want to say something else.
No, I believe. Well, thank you guys for watching, for inviting me. That was a nice experience. This was the first presentation online for me. First talk online. This is not really.
Oh, go ahead. Sorry.
Yep.
Yeah, I'm just going to stop recording real quick. So